Hello, great students. I am Ochuko, your exam KP mathematics teacher. Now, let me tell you, this topic is an absolute powerhouse. It's not just some isolated math concept you forget about. No way. This is the engine that drives commercial math, and you'll see it pop up everywhere in physics and chemistry too. The best part? It's a guaranteed question area in your WAEC, JAMB, and NECO exams. So mastering this, that's your direct ticket to a top grade. So here's our game plan for today. First, we'll talk about why this is also critical. Then we'll build up the core concept, the basics. After that, we'll see how it all applies to rates. And then the fun part, we'll put everything to the test with real past questions before we wrap up with a winning exam strategy. Sound good? Ready to become a ratio master? Let's jump right in. All right, first things first. Why are we even dedicating all this time to ratios? Well, it's simple. A solid understanding of this stuff isn't just kind of helpful. No, it's your direct key to unlocking more points and seriously boosting your overall exam scores. Okay, so here's my promise to you. By the end of this, you're going to be able to confidently handle these three essential skills. You'll be sharing quantities without a second thought. You'll look at a question and know exactly which type of variation it is. And you'll finally be able to solve those tricky word problems about speed or work. We're talking about guaranteed marks in your pocket. So let's go get them. All right, let's get into the real meat of it, the core concepts. We've got to start with the building blocks, right? This is the foundation that everything else, I'm talking everything from sharing profits to calculating pump speeds, is built on. So, what is a ratio? Well, it's just a simple way to compare quantities. The best way I like to think about it is like slicing a cake. So in this example, our cake is 7,200 naira. First things first, we need to know how many slices there are in total, right? So we just add up the ratios, 3 plus 4 plus 5. That gives us 12 total parts. Okay, next up, we figure out how much each single slice or part is worth. We just divide the total amount by the total parts. So 7,200 divided by 12, that's 600 naira per part. Now for the easy bit. A cake gets 3 of those parts. So that's 3 times 600, which gives us 1,800 naira. See? Simple as that. Okay, now this is really interesting. Here we've got two powerful but totally opposite ideas. Let's start with direct variation. Think of it like a perfect partnership. As one thing goes up, the other goes up right along with it. Makes sense, right? Like the more hours you work, the more money you earn. They move together. But inverse variation, that's more like a seesaw. As one side goes up, the other has to come down. Think about it. The more people you have painting a house, the less time it's going to take. One goes up, the other goes down. Total opposites. So now that we've got a handle on these core relationships, the partnership of direct variation and that seesaw of inverse variation, let's see how they actually play out in the real world when we start talking about rates of change. So a rate, it's really just a special kind of ratio that measures change, and usually it's change over time. Think about the speed of a car in kilometers per hour. That's a rate. Now, what about joint variation? I know it sounds a little complex, but trust me, it's not. Imagine you are painting a giant wall. The area you can paint depends on two things, doesn't it? The number of friends you have helping you and how much time you spend painting. The more friends and the more time, well, the more wall gets painted. That's all joint variation is. One thing depending on two or more others all working together. All right, team, this is where the magic happens. We've done the theory, now it's time to get our hands dirty with actual past questions from WAEC, JAMB, and NECO. Think of this as your training ground for the real exam day. You ready? Let's do this. Okay, here's a classic WAEC problem. You'll see this kind of thing a lot. They give you two separate ratios and you have to connect them. Now, the key to this whole puzzle is the person who is in both ratios. In this case, that's B. So our very first job is to make B's share equal in both ratios. Now listen up because this is important. The biggest mistake students make is trying to add the ratios just as they are. You can't. You just can't. We absolutely have to unify B first. So we find the LCM of B's parts, which are 3 and 4, and that's 12. Then we scale up both ratios to make B's share equal to 12. And just like that, we create our single powerful compound ratio, 8 to 12 to 15. Now we can solve it just like that cake problem from before. Sum up the parts to get 35 and then calculate B's share. This is a perfect example of why that first step is so important. Okay, let's break this one down. As soon as you see those keywords, varies inversely and square root, your brain should be screaming formula time, right? So time, T, is on one side. Inversely tells us that the pumps, P, go in the denominator. And whatever you do, don't you dare forget that square root. It's crucial. Okay, here's the golden rule for all variation problems. You absolutely must find your constant K first. Always. This K is like the secret code that unlocks the entire problem. It defines the specific relationship for this specific tank and these specific pumps. So we plug in the first set of values they gave us. 40 minutes for 4 pumps, a little math, and that tells us K equals 80. Now we have our master formula. T equals 80 divided by the square root of P. And with that, we can solve for anything. Stick in 16 for the pumps, and you get 20 minutes. Done. Now, this is a really common style of question in JAM, so pay attention. They are not asking for a final number here. What they want is the rule, the actual equation that connects E and V. So, when you read E varies as the square of V, you should immediately translate that into math in your head. E equals K times V squared. That's it. Now, all we have to do is hunt down the value of our old friend K. Just look at how straightforward this is when we follow the steps. Step 1. Set up the relationship. E equals K times V squared. Step 2. Plug in the numbers they gave us. 72 for E, 6 for V. A little bit of simple algebra and boom, K equals 2. And for the final step, we just slot that value for K right back into our original relationship. What do we get? E equals 2 times V squared. And that is a perfect match for option A. Nice and easy. All right, let's tackle this joint variation problem. Don't let it scare you. We just break it down piece by piece. W varies directly as X. Okay, that means X goes on top in the numerator. Then, and inversely as the square root of Y. All right, that means the square root of Y goes on the bottom in the denominator. So let's put it all together into one single formula. So first we build our formula. W equals Kx over the square root of Y. And then what do we do next? You guessed it, we find our constant K using that first set of data they gave us. A little rearranging and we see that K equals 4. Perfect. Now we have our complete master equation for this entire relationship. W equals 4x over the square root of Y. For the final step, we just plug in the new values. X is 5 and Y is 25. That gives us 20 divided by 5 and our final answer is 4. See? Just follow the process. Okay, this is a great one. A really practical work rate problem from NECO. Think about it logically. The number of bottles a factory can make depends directly on two things, right? First, how many machines are running, and second, how long you run them for. This is a textbook classic case of joint variation. So let's just follow the steps. Our basic relationship is that bottles produced equals some constant K times the number of machines times the time. Simple. We use the initial data to find our constant, our factory's efficiency rate, you could call it, and that turns out to be K equals 30. Now for the second part. You've got to be careful here. 4 machines break down, so we're left with only 4, but the time is now 10 hours. So we plug these new numbers into our formula and we get 1,200 bottles. Hold on a second. That's the same amount. Isn't that interesting? It just goes to show you that even with half the machines, doubling the working time balanced it out perfectly. You guys have done some fantastic work. We've tackled the theory, we've battled through real past questions, so now let's pull everything together into the essential toolkit you need to walk into that exam hall feeling totally confident. Okay, here they are, your most valuable formulas, all on one slide. I want you to burn these relationships into your memory. For any variation problem, your very first move should always be to write down the correct formula. And for any speed problem,
Please remember, it's always total distance over total time. There are no shortcuts. And finally, let's talk about the traps. These are the things I see students catch out year after year after year. Please don't let this be you. First up, the average speed trap. Never, ever, ever just add 2 speeds and divide by 2. It's a trick and they want you to fall for it. Second, never forget to find K. I know I'm sounding like a broken record, but it's the key that unlocks the whole problem. And third, watch your units. If they give you minutes and hours or kilometers and meters in the same question, you have to make them consistent before you start calculating. Trust me, avoiding these simple slip-ups is the difference between a good score and a truly great score. Thank you for watching. Don't forget to like, share, and subscribe to our YouTube channel. And visit www.examkp.com for more practice questions.